Using the temporary variable, we are going to exchange or swap the data items present in 0th location. So in this case, we have 8 data items. That is the length of an array. We have a value 7 which is greater than 1, so we have to swap these items from here to here. The logic of this shell sort works on the principle of interval. Hello everyone, it is Dr. Ravikumar YB. In today's session, we shall learn about the working of shell sort, which is one of the important sorting technique which you have come across in the unit 1 of your syllabus. That is, in this shell sort algorithm, you are going to sort the elements either in the increasing order or in the decreasing order. Suppose if the elements are sorted in random manner, then it has to be sorted either in the increasing order or in the decreasing order. That is the goal of this today's session. In today's session, we have the shell sort with this example wherein you have these 8 data items. That is, the first data item which is located at the 0th location is this. First location is 8, second location is 3, third location is 7, fourth location is 5, fifth location is 6, sixth location is 4, seventh location is 1. So totally we have ranging from 0 to 7, so totally 8 data items are there. So in this case we have 8 data items, that is the length of an array. It is randomly placed in this array. Now I want to sort it in increasing order. If that is the case, which elements comes first? This has to reach the first position and this has to reach the last position. So this is the initial status of this array. So now we shall employ the shell's original sequence, that is n by 2, n by 4, n by 8, so on like that. Suppose if you had the 16 as the length of a data item, then you should have been used to have the data items of the form of n by 2, n by 4, n by 8, n by 16, so on like that until you get the value 1. That is, in this case, what is the value of n? Let me consider there are 8 data items. So if that is the case, 8 by 2 is initially is equal to 4. This is one of the interval, that is first interval. Next time when it is incremented by 2, that is 8 by 4, it becomes 2. This is the second interval. Next time it is further incremented by 4, that is the double of this, that is 8 by 8. We have one data, that is the third interval, that is one item, until we obtain the value 1. In case if the number of data items are is equal to 16, then there is a possibility of having the other term, that is 16 by 2 is equal to 8, 16 by 4 is equal to 4, 16 by 2 is equal to 16 by 8 is equal to 2, 16 by 16 is equal to 1. So totally we will come across the value ranging from n by 2 to 1. So this is the concept we are using here in case of shell sort. In case of shell sort, we have this procedure as an interval. That is, the first interval is obtained at 4th position. That is varying from 0, 1, 2, 3, 4. This is the first interval from here to here. Next, which is the second interval, 0 to 2, second position, 0, 1, 2. This is considered as the next interval. Then one item is there. So this is considered as the another interval. So we are going to reduce the interval from half of that. That is from 8 to 4, 4 to 2, 2 to 1. So we are going to do that kind of interval changes here after every iteration. So if that is the case, we shall see the working of that. In the first loop, the same thing is explained here. The array size is n is equal to 8. Then each element lying at the interval n by 2 is equal to 4 are compared and swapped if they are not in order. That is, if they are in random order. Then 0th element is compared with the 4th element. That is, this 4th element. Using the temporary variable, we are going to exchange or swap the data items present in 0th location with 4th location. So this process is continued until the completion of n by 2, n by 4, n by 8 in the present iteration. So let us move on forward as to how we can find out the sorted array using the concept of shell sort. In this case, you will see that this is the 0th element and this is the 4th element. If that is the case, we are going to compare the items present at this location with this location. What is that item present in that location? If I call this entire thing as an array, and if a of 0 is greater than a of interval. What is that interval? That is n by 2. If this is the case, swap the items present in this location. How you are going to swap that? Using the temporary variable, that is this a of 0, that is initially 5 is assigned to that, that is a of n by 2 is assigned to temp, and then this is assigned to this value, that is a of 0 is assigned to a of n by 2 location, then temp is assigned to this a of 0th location, that is a of 0th location. So with this, we are going to swap the items from here to here and here to here. So with this, the resultant of this operation is this item, that is 9 is swapped into this position and 5 is placed into this position. After the result of this operation, we are having this 5 in 0th location, 8 in first location, 3 in second location, 7 in third location, 9 in fourth location, 6 in fifth location, 4 in sixth location, 1 in seventh location. So this is the item we have after the n by 2 interval arrangement. That is by considering this. In the next step, what happens? It is further divided. The interval is further divided. That is n by 4. n by 4 is 8 by 4. Obviously, that becomes equal to this interval, n by 4. That is 8 by 4 is equal to 2. We have the value 2 here. So, if that is the case, 0, 1, 2. This is the second interval. In this case, again, this is compared with this. Again, this value is greater than this item. So, we are going to swap that. That is, this item is brought to this position and this item is brought to this position. As a result of that, we are going to get the array of type 2, 8, 5, 7, 9, 6, 4, 1. As a result of this n by 4 operations, in the next slide, you will see that. Now, you are going to see that 5 is here, 8, 3, 7, 9, 6, 4, 1. Now, by doing this, we are going to get 5, 6, 3, that is 2 is compared, that is 3. In the second position, we have the value 3 here. So, 3 is placed into this position, 5 is brought to this position. So, we have 3, 8, 5, 7, 9, that is this. 3 is brought to this position. So, totally after rearranging this term, it turns out to be 3, 6, 5, 1, 9, 8, 4, 7. So, if that is the case, what is the process I am going to do now? In the second loop, we have 8 by 4 is equal to 2 again. In the first loop, we have this term, that is 583799641. That is how we are going to do that. Let us see to it. In the first iteration, again 6 is compared with 4. That is, this is the 0th position. 1, 2, 3, 4, 5. So totally we have 6. This is going to be compared and swapped with this. The same thing is done in the previous iteration. That is, 6 is brought to here and 8 is taken to this position. Now we have the value which is shifted from here to here. So 0, 1, 2, 3, 4. So 3 is swapped from here to here and 4 is brought to this position if it is greater than that. But in this case, 3 is already lesser than 4. So it is no swapping is done. So again 7. Since 7 is in this position, this becomes 0, 1, 2, 3, 4. Again, we have a value 7 which is greater than 1. So we have to swap these items from here to here. So in the resultant equation, in the resultant array, we are going to get 5, 6, 3, 1, 9, 8, 4, 7 as a result of this n by 2 operations in the first loop, in the first iteration. In the next iteration, that is in the next loop, we are going to use this as input in the second iteration. In the second iteration, we are going to use this. Again, we have the term ranging from n by 2 interval, that is n by 2 is equal to 4. We are going to consider this as 0th position and this as 0, 1, 2, 3, 4. Now, 5, 6, 7. Now we are going to consider these terms, value ranging from here to here as an interval, first interval, in the second iteration. See here, 5, 6, 3, 1, 9, 8, 4, 7. Now, what is the value we get? N by 2 means 4. In this case, we have the value which is n by 4 because we have in the second iteration. In the second iteration, what is the value we are going to get? We are going to get n by 4. N by 4 means what? This is n by 2 when in the first iteration. During the second iteration, n by it is 4. That is during the second iteration. That is next n by 8, that is equal to third iteration. Now in this case we have the data item. Since we are in the second iteration, we are going to multiply this with the iteration number. What is that? If I generalize this term, n by 2 initially is obtained, 2 is obtained by multiplying it by what? In the first iteration. This has to be multiplied by n by 1 into 2. The next, that is in the first iteration. In the second iteration, n by 2 into 2, that is in the second iteration. If that is the case, n by 3 into 6, 3 into 2, that turns out to be a 6. But what is required there? We require n by 8. If that is the case, what has to be done? This has to be in terms of 2 raised to the power of n. 2 raised to the power of n. If that is the case, let me rewrite this in these terms. That is n by 2 raised to the power of 1. That is equal to the first iteration. N by 2 raised to the power of 2 turns out to be the value n by 4, that is second iteration. Then n by 2 raised to the power of 3 turns out to be the third iteration. Then what is the value of n? If I generalize this term, that is n is equal to 8, 8 by 2 is equal to 4, 8 by 4 is equal to 8, that is 2. 8 by 4 is equal to 2. 8 by 8 is equal to 1. Are we getting the results properly here for this? So this could be the generalized formula to obtain the number of intervals to be followed in every iteration. That is, again, in case of this, n by 2, that is, we have n by, in the second loop, we have n by 4, that is the value n by 4. Oh, I am getting the n by 4, that is this value. In the third iteration, what happens again? It is n by 2 cube. Begins at n by 2 cube. So if that is the case, let us see to it in the second loop. That is 5 and 3 is compared. Oh, n by 4 is equal to 2 here. 0, 1, 2 are the interval. So if that is the case, since 5 is greater than 3, we have to swap these data items. So this becomes 3, 6, 5. So after swapping, we get this. Next, what happens? This becomes your 0th position, 1, 2. Since 6 is greater than 1, we have to swap these two terms. So this becomes 3, 1, 5, 6. That is 3, 1, 5, 6 here. Then again, this is the next interval. If in this case, which is the item, since 5 is less than 9 already, no need to swap. I will move on to the next location. That is this. Since 6 is less than 8, there is no need to swap. Again, 9, this and this. 9 is greater than 4. So it has to be swapped to this position. 9 has to be brought to this position. So 9 is brought from here to here and 4 has to be brought from here to here. That is, you are going to see in the next iteration. 9 is brought from here, there to here, and 4 is brought from here to here. That is, 9 is to be brought from here to 4 and 4 is to be brought from here to here. So if that is the case, we have obtained the same process here. If that is the case, 9 is brought from here to here and 4 is brought from here to here. Now, after that, again, the iteration follows. That is, again, 0, 1, 2, 3, 4, 5, 6, 7. This process is followed. That is, 0 to 4 is 0 to 4. N by 2, that is 4 items are considered initially. Now, in this case, if you look at the previous example, that is in this case, you have after this first loop, you have this term. That is 5, 6, 3, 1, 9, 8, 4, 7. This is after the first loop. After the operations of this, you are going to get this term. That is 3, 6, 5, 1, 9, 8, 4, 7. Next, rearranging the data items from here to here in the n by 4 intervals, you might get confused at this point. So please don't get confused. Here we have 3, 1, 5, 6, 9, 8, 4, 7. So this has to be swapped because since 9 is the item which is greater than 4, this has to be swapped. But what happens then if I brought this from here to here and 9 is brought from here to this location? 3, 1, 5, 6, this becomes your 9th, this becomes your 4, and this becomes 8, and this becomes 9, and 7 remains as it is in that location. Then again, it is shifted from here to here. So if that is the case, 8 is greater than 7. So 7 is to be brought from here to here, and 8 is to be brought from here to 7. So if that is the case, what is the resulting information we have? 3, 1, 5, 6. 3, 1, 5, 6. 3, 1, 5, 6. 4, 7, 9, 8. This is the value we have obtained after the second iteration, second loop. Second time the loop is executed, we have got this information. So all the information which are there in the second iteration are going to be used in the third iteration, that is in this case, that is 3, 1, 5. 315 64798. 315 64798. The same thing is going to be used here. 315 64798. In the third iteration, or in the third loop, it is n by 8. What about n by 8? When we have the values which are ranging from n by 8, that is 8 by 8 is equal to 1. What happens then? Then this item is exchanged with this. That is, if that is the case, as a result of this 1, 3, 5, 6, 4, 7, 9, 8, then this is swapped with this, but it is already in the order, so no need to swap. 5 is with 6, no need to swap. Again 6 with 4, so in that case 4, 6, 7, 9, 8, 1, 3, 5. Again 4 with 6 is over. 6 with 7, not possible. 7 with 9, not possible. 9 with 8, yes, it is possible. 8, 9, 7, 6, 4, 5, 3, 1. So with this, we are going to get this type of value in third iteration. During the fourth iteration, what happens? Again, during the fourth iteration, again, the value from 1, 2, 3, 4, 5, 6, 7, 8. We have the terms ranging from 0 to 7. So if that is the case, what happens? So 0, 1, 2, 3, 4. This becomes your term, middle term in the first interval. That is, in this case we have, since it is already sorted and it is in order, no need to swap. That is 1, 3, 5, 4, 6, 7, 8, 9. No need to swap. 3 with 7, no need to swap. 5 with 8, no need to swap. 4 with 9, no need to swap. Again, then interval is reduced by 4. Then in that case, what happens? 0, 1, 2. This is my new interval. So 1 is already swapped. That is, let me take 1, 3, 5, 4, 6, 7, 8, 9. Now 1 must be swapped with this? No. 3 with 4? No. 5 with 6? No. 4 with 7? No. 6 with 8? No. 7 with 9? No. That is not possible. Again, n by, this is for n by 2. This is for n by 4. This is for n by 8. Now we have this resulting. That is 1, 3, 5, 4, 6, 7, 8, 9. Now we have 1 with 3, no. 3 with 5, no. 5 with 4, yes. That is 4, 5. 5 with 6, no. 6 with 7, no. 7 with 8, no. 8 with 9, no. So rest of the things are kept as it is. So ultimately we get the items in this range 1, 3, 4, 5, 6, 7, 8, 9. So this is the value we obtain at the end of fourth iteration. At the end of fourth iteration, we will get the output in the sorted order, which is going to be shown to you in the next slide. That is this slide. Finally, we have 3. Initially, that is 3 with 1. Yes, 1 with 3 swapped. Then 3 with 4, no need to swap. 4 with 6, no need to swap. 6 with 5, yes, need to swap. Brought from here to here, that is 5 with 6. Then 6 with 7, 7 with, no need to swap. Then 7 with 9, no need to swap. 9 with 8, need to be swapped. The same thing is done here, 9 to 8, the same thing is done. Ultimately, at the end of this, you will get 1, 3, 4, 5, 6, 7, 8, 9. This is sorted. 1, 3, 4, 5, 6, 7, 8, 9. This is the sorted order. So by doing this, you will see that the logic of this shell sort works on the principle of interval. Then how you are going to find out the interval? That is the length of an array divided by 2 raised to the power of the iteration number. That is the length of an array divided by 2 raised to the power of iteration number. That gives me the total number of iterations required to sort the entire array. Suppose if there are 16 data items, 16 by 2 raised to the power of iteration number, that is first iteration, that is 16 by 2 is equal to 8. Then 16 by second iteration 2 raised to the power of 2, that is equal to 16 by 4, that is equal to 4. Then 16 by 2 raised to the power of 3, that is 8, is equal to 2. Then 16 by 2 raised to the power of 4, that is 16 by 16, is equal to 1. So until the swapping between single data items takes place, this process is repeated. Let me take one more example to illustrate the working of the shell sort. Here we have only 1, 2, 3, 4, 5, 6. Since it is in sorted order, how many items are there? 0, 1, 2, 3, 4, 5. Totally 0 to 5 means 6 items are there. That is the length of an array. If that is the case, n by 2, that is n by 2 raised to the power of 1 is equal to what? 6 raised to the power of 2 is equal to 3. This is my first interval. Then n by 2 raised to the power of 2, that is equal to what? 6 by 4. Again you will get the value which is in the fractional part. That is this. 4 ones are 4, that is equal to 1 point something value you will get. So that is the floor division of that is taken together and this becomes your 1. That is in the second iteration. That is in the second iteration. Now we have the terms like this. So let me consider in the first iteration we have only this interval. If this is the case, we have already sorted. I want to sort it in the decreasing order. Let me consider this as 21, this as 20, this as 31, this as 42, this as 51, this as 60. So we have all these terms in sorted or unsorted order. I want to sort it. So 21 is less than 31, no need to sort. Then 20 is compared with 42, already sorted, no need to sort. 31 is compared with 51, already sorted, no need to sort. 52 is sorted with 60, already sorted, no need to sort in the first iteration. In the second iteration, then again in the next iteration, we will consider the length of interval between this to this, that is 21, 20, 31, 42, 51, 60. Now these individual data items are considered, that is the length gets reduced from 3 to 1. What is floor division? That is 6 by 4 is equal to 4 ones are 4, that is 1.2 is there, 1.5. What is the floor division of that? It is taken to be equal to 1, that is rounded off to 1. If I had taken the seal of that, this would have become 2, but in this case we are taking the floor division of this, not just division, it is a floor division of this, that is it works on the principle of floor division. So this becomes the value 1. So in the next case what happens? The next interval begins from here to here. 21 is greater than 20, so 20 becomes here, 21 comes here. Then 20 with 31 already sorted, no need to consider it. 31 with 42, no need to consider, 42. 42 with 51, no need to swap, that is 51. 51 with 60, no need to swap. So this is the entire array which is sorted in the increasing order. So if that is the case, we are going to consider the logic of this in the form of an interval. Let me consider one more example to illustrate the shell sort for your convenience of understanding. Here we have the terms varying from, let me consider one more array, 15, 10, 11, 30, 55, 65, 90, 18, 1, 2, 3, 4, 5, 6, 7, 8. 8 data items are there in this case. This is at 0th position, 1st position, 2nd position, 3rd position, 4th position, 5th position, 6th position, 7th position. So 0 to 7 is there. So 8 data items. If that is the case, during the first iteration, what happens? n by 2 raised to the power of 1, that is total number of items equal to 8, 8 by 2 is equal to 4. This is my first interval. In this case, 0 is considered as this, 0, 1, 2, 3, 4. This becomes your interval range, that is this. Now, I want to say that 15 is greater than 55. No need to swap. 10 is compared with 65. No need to swap. 11 is compared with 90. No need to swap. 30 is compared with 18. Need to be swapped. In that case, what happens? 18 comes here, 55, 65, 90, 30 goes to this position. 15, 10, 11 remains here. That is after one pass. In the next pass, what happens? This becomes n by 2 raised to the power of 2. That is in the second iteration. That is 8 by 4 is equal to what? 2. That is in the second iteration. You are going to have this. Second ITER. Second iteration. In this case, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7th position. 2 is the length of the item, interval. That is from here to 0, 1, 2. This is the interval. Initially, since 15 is greater than 11, we are going to swap that. 11, 10, 15, 18, 55, 65, 90, 30. Then this item is compared with this item. It is already in sorted order because 10 is less than 18, no need to swap. Then 15 with 55, no need to swap. Then 18 with 65, already sorted, no need to swap. 55 with 90, already sorted, no need to swap. 65 with 30. Since 65 is greater than 30, so it has to be brought here and 65 must be taken to this position. Swapping is needed. So this becomes 30, 90, this becomes 65. Now the remaining elements remain same in the same position, 18, 15, 10, 11. Now this is after the result of this. When n is equal to n by 2, n by 4 is equal to 2. 8 by 2 raised to the power of 3, that is equal to 8 by 8 is equal to 1 in the third iteration, in the same. Now, this in the same iteration, that is in the second iteration itself, that is 1. This is the interval. Since 11 is greater than 10, it has to be swapped. So this becomes 10, this is 11. 10 with, and then 11 with 15. Yes, it is already sorted. 15 with 18, it is already sorted. 18 with 55, it is already sorted. 55 with 30, is it possible? No, it has to be brought from here to here. So this becomes your 30 and this is your 55. 18, 15, 11, 10. Now 90 is here, 55, 65 is here. So 30 is brought from here to here and 55 is taken from here to this position. Now 55 with 90, it is already sorted. 90 with 65, yes, there needs to be a swap. So as a result of this, 65, 90, 55, 30, 18, 15, 11, 10. Is there any chance required to sort it once again? No need to swap or no need to sort because 10 is less than 11, 11 is less than 15, 15 is less than 18, 18 is less than 30, 30 is less than 55, 55 is less than 65, ultimately 65 is less than 90. So it is in the sorted ascending order. So if that is the case, we shall see the logic of this in the form of a program. See here, this is the floor division symbol I am using here, that is the floor division symbol. That does the task of reducing the interval linearly, that is from here to this, n by 2 to n by 4, n by 4 to n by 8, n by 8 to n by 16, until we get the value 1 in the length of an interval. That is, initially. N is N floor division 2. Interval, what is the interval we have here? We have an interval that is equal to, suppose if I consider 8 as the length of that, 8 by 2, floor division of that is 4. Interval becomes equal to 4. 4 greater than 0, yes. I in range of 4 comma 8. 4 comma 8 means what? 4, 5, 6, 7. These terms are considered in case of Python, excluding 8, that is 4, 5, 6, 7. Temp equal to array of I. What is the value of I? I varying from range from 4 to 8, that is 4, 5, 6, 7. 4, 5, 6, 7. So array of I, array of 4 is compared with, is assigned to temp, and j is equal to I. Then j is greater than or equal to interval, and array of j minus interval is greater than temp. This is the condition that helps me to swap the interval, that is to consider the interval ranges, that is from here to here, array of j minus interval to array of j, and j minus equal to interval. That helps me to reduce the interval by n by 2, n by 4, n by 8, so on up to 1. So if that is the case, in the next iteration what happens? 4 becomes interval. What happens? This here, interval floor division 2. Then this becomes n by 4. N by 4 means what? Again, this comes to here. N by 4 means what? This becomes 8. 8 becomes, 4 becomes 2. That is this 2. 2 is greater than 0? No. That means, yes, it is greater than 0. Then we have 2 here, 2 in the interval position. N is what? What is the value of n? 8. So the interval exchange is going to be taken place with the help of, at the distance of 2 intervals. Then again it is decremented by 2. That is 2 becomes, next it becomes 1. Here it becomes 1. 1 greater than 0? Yes, the 0 and 8. What is the length of that? 8. So 0 to 8, after every element we are going to swap that. That is this. So finally, this is the initial data item we gave, and the length of that is considered here, and the sorted array is displayed at the end. That is 1, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Totally all these items are displayed in this order, in ascending order, in the place of print data. Then if that is the case, what happens? What is the shell sort complexity? In the best case, it is n log n. In the worst case, it is n square, because we have the number of iterations equal to 2 power n. So we have the average case as n log n. Then what is the space complexity required for this? Big O of n, big O of 1, where n is equal to 1. Then the stability, there is no stability in this, because after every iteration, it has to be, the interval must be reduced by 2 raised to the power of the iteration number. So that's why there is no stability in that. This is the details of shell sort. Thank you all. With this, we are going to conclude the session on shell sort. Thank you all.